I'm trying to share my screen
Awesome.
again. Okay. I think we should be in luck.
Yep, it's working. Awesome.
Yeah, so yeah, as you mentioned, any work with 3D plans, BIM has to start with reality capture or laser scanning, or however you want to call it, because for everything scan to CAD or scan to BIM, there's always the scan step coming first. There are different ways to capture data. It can be as simple as going with a measuring stick and measuring rooms in buildings. It's probably not the most efficient way these days. Back in the day, it was the only way, but technology, thankfully for us, has moved forward a long way. So what we do as NavVis is we make capturing spaces as easy and as fast and affordable as possible, as technology allows us doing it now. The company itself is about 300 people. It received over $100 million from VC investors because the software that my colleagues and the engineers at NavVis were able to develop cannot be yet cracked by anyone else. That's our secret sauce. How do we get this data so fast and so clean and so accurate? And yeah, talking about really capture, the whole world is pushing into BIM and digital twins. When it comes to folks in the AEC industry, most of them are still stuck in 2D environments. But there's a big push where everyone is moving to 3D and beyond 3D when they realize how much time and resources they could be saving.
Mhm.
Looking from a historical point of view, how we got here where we are, everything started with digital total stations 40 years ago, where you could do the most accurate point-to-point measurements. Then 20 years ago, first static scanners started coming out, which is the next step from total stations. Terrific data, extremely accurate. Pretty much all of my clients, besides NavVis scanners, buy static scanners, but they're just very slow. They can probably capture 3,000 or 4,000 square meters per day. And at the end of the day, clients want the lowest price per square meter. So if you have so many man hours in a field to put with a static scanner, how do you lower the price of scanning? With our scanners, you can scan 10 times faster than static scanners, meaning you can easily capture 20, 30, 40,000 square meters per day because it's a different way of capture. You're not just placing a scanner, waiting a couple minutes to spin, then moving it to another location and spinning it again. Like you see on the left side of the screen, you constantly walk around the site. So as you walk through, and I will play a little video in a few seconds, it's hard to explain with words. It's always easier to explain with a video. But as you walk, you constantly capture point clouds and take 360 panoramic walkthroughs. So in our offering, we have two hardware pieces and a software piece, which is a web viewer, can display virtual walkthroughs / digital twins or the point clouds. Playing a little 2-minute video right now to show you how this scanning is taking place. First of all, it doesn't look much like a laser scanner. We are laughing around. It looks more like a Star Wars weapon than a tool you'll see on a construction site or in a building. But it's very easy to use. It needs less than 5 minutes to set up on site. It weighs 8 kilograms, and it feels just like wearing a backpack, like going to school or going hiking. And all the operator needs to do is just walk through the whole space they want to scan. The point cloud is built automatically, and every time they stop, they take a photo. Obviously, we don't want photos to be blurry, so it's good to stop for a second and take a nice sharp photo. But the whole process of manual placements got fully automated. To improve line of sight, people can use it oversized handheld devices and are reaching above or below or between objects, like in mechanical rooms and tight spaces. The device generates a live 2D floor plan, which feels like playing a video game and uncovering the map, which means it's virtually impossible to miss any rooms in a building, because you will have a blue map with a bunch of black holes on it, so you just have to zoom out, see which rooms you missed, and go back to them before you leave the floor. Creating point clouds is not everything we do. There are 4 cameras on the scanner that take nice 360 panoramic images. So afterwards, you get this immersive experience that you have something that looks like Google Street View of your project site, of your building, or of outdoors, but there are point clouds behind it, and you can switch from one to another. So for folks who are doing BIM, especially when the BIM is outsourced to another country, another location, those virtual walkthroughs help a lot, because if something is not clear in a point cloud, they just open a photo and they know exactly what it is. So more about the device itself, I can explain the room and showing some examples of the data, just very quickly going through. Our data can be tied into survey control if needed. Doesn't have to. Looking at what are we competing against in the mobile scanner industry, because yes, mobile scanners have been around for over 10 years, but we are the first scanner that can compete with static scanners head to head with respect to data quality and accuracy. What you see on the screen right now are our three main competitors and their respective point clouds. And this is the point cloud for the VLX. It's a night and day how much more accurate and more clean our data is. In some cases, if you look from far away, you might not be so sure it's a point cloud or a photo. So a lot of people don't even realize that mobile scanners have time that long to take such nice point clouds. Talking about mechanical rooms, talking about any other buildings for SCAD, scan to CAD, scan to BIM. The data is super nice and sharp to do drawings, plans. You can scan any type of space. This is the Oculus in Manhattan, where I'm based in our New York City office. Took me 10 minutes to scan the structure. It's a big shopping mall across the street from the World Trade Center. And another day I took it for a walk across the Brooklyn Bridge, zigzagging through the middle deck, watching out for runners and bikers. And in 45 minutes, I scanned the whole bridge. So there's a lot that VLX can do, as long as a person and the scanner can fit into that space. And, talking about accuracy, we are more than accurate enough for architecture and construction type projects. We are not accurate enough for high grade engineering projects. It's all about using the right tool for the right job. And going through with the presentation, I will go back to my booth. I don't want to keep everyone too long in my part here. This is just a little teaser of what we do. The visual aspect of our point cloud, just looking around, similar to Matterport, but way greater photo density, because it takes us 1 second to take a photo. So this viewer helps a lot for the BIM people to see something which is not visible in the point cloud. But talking about even simple stuff for folks who want to take measurements. So for example, I'll quickly here, look at the ceiling, drop a measurement, and I can see how tall the ceiling is. I take area measurements and things like that. And finally, looking at the point clouds, just load the point cloud. It's all streaming in a browser. This can be integrated into other software, just a web link, so you can bring as an iframe anywhere. But looking at the data quality that comes from this mobile scanner is unlike any other mobile scanners. You can almost see individual books in the back. And let's just go outside. This building has been scanned everywhere. Going on the street. And just showing you indoors and outdoors.
Awesome. So yeah, you mentioned that there is obviously a possibility to georeference the point cloud, right? It for SLAM technology, it's something that was not very it was not common. Is it something new that you just introduced? And how does that work?
Yep. So we introduced it a couple of years ago with our previous generation scanner. Let me see if I have this slide right here. So yeah, most other mobile scanners from like other manufacturers, they just give you a relative scan and they have no way of tying into survey control because they just have a Velodyne on a stick. Let's call it like this. We have this metal pin. The arrow is actually white that you touch all the control points, and those could be nails in the ground or stickers, or it could be even checkerboards from static scanners. And every time you touch a point, the scanner saves this point to the point cloud. And then our software uses all those points as kind of nails in a point cloud to stretch it or shrink it or tilt it or level it, making it more accurate. but then also using the same points to like drop it on a map in whichever coordinate system you want to export the data. So it can be local, state plane, global. You just take this data later and translate it the way you want. But yes, you need some points of physical reference in the scan to connect it with reality if you want this to be placed where you want to be. If you have any other, mobile scanner, handheld, or whatever, it's just gonna give you a relative scan that is not able to even tell you what was the error of the measurement. Because we touch the points, which can be measured total station, we can give, all the errors of how the scanner performed versus a licensed surveyor of a total station who measured those points.
Awesome. Yeah, that's great. That's great. Thank you so much. If there are any questions, you can type it in your in the chat, and we will be able to respond during the presentation. Or obviously, every one of us will have a possibility to talk to you at the booth. Great presentation so far. Thank you so much, Ishita and Marek. And I think I'm next on the list. So let me quickly share my screen. Right